Alright, now we're going to go a little bit further. And instead of working just with equations, we're going to work with inequalities. Now, just a few little reminders before we begin. Remember that you solve inequalities the same way that you solve equations. The only difference here is that we have one added rule, and that is you have to remember if you multiply or divide by a negative number, then you must flip the symbol. Must flip the symbol. So meaning the less than or the greater than symbol. You have to flip those over if you multiply or divide by a negative. Otherwise, the rules are exactly the same as they are for solving equations. Now, another thing that we need to review back is the ands and the ors. If you'll remember, an and statement is the same thing as an intersection, where we talked about in the previous section. And an or statement is a union of sets. So we have to remember that. Now, to help you remember which one is which, when you see the less than sign, that's an and statement or an intersection. A greater than statement is an or a union. So the way that I remember it is I say less than and I hear the and in there. Or I say greater, the or. So maybe that'll help. Okay, let's try one. This one says solve the absolute value of x is less than 9, then graph the solution. Alright, well, first of all, is this an and or an or statement? Because it is a less than, that's telling us that this is going to be an intersection or an and statement. So now let's use what we know. We know that what's inside this absolute value, we could look at it as the positive, would be less than 9. And we could also look at it as the opposite. So the opposite of x could be less than 9. Alright, x is less than 9 is done. There's nothing else we can do to it. But negative x is less than 9 is not done. We really do need to get this x all by itself. So if we divide both sides by a negative 1, that means that we would have x over on the left, we would have negative 9 on the right, and because we divided by a negative, we have to flip the inequality symbol over. So now our answers look like the x is less than 9 and the x is greater than negative 9. Now both of these conditions have to be true in order for the whole entire thing to be true because of it being an and statement. So let's draw this out so we can see it a little bit better. Okay, here's 0. Let's say 9 is over here and negative 9 is over here. The first statement, x is less than 9. Well, that would be from 9 back to the left. And the x is greater than negative 9 would start at negative 9 and move to the right. Now we want to know where both of those things are true at the same time. And if you think about it, let me extend my line out here just a little bit on this one. Let's say that we were talking about this point right here. It would only be true in this part of the equation, not in this one. So it's not in x is less than 9 and greater than negative 9 because that's not true. Like let's say that was a negative 10 there. In order to be in the and solution, it has to be true in both. So we're looking at where they overlap. Well, in this case, they would overlap starting here at negative 9 and going all the way over to a positive 9. So this would be the graphical answer. And as far as interval notation, we have to write that straight off the graph, parenthesis, negative 9, comma 9, and close the parenthesis. So that would be our interval notation.